All right, guys. I appreciate the time today. Sorry it took us a little bit longer to get set up here. Was the hackathon successful? I would say yes to one degree. We couldn't get some of the stuff working on my laptop. Trying to run a full val Blue Planet with 16 gigs of memory on my laptop proved unsuccessful. Crashed a few times and corrupted a few files. But we did manage to get through it in a demo, and I think conceptually, once we go back to the lab, we're going to be able to set everything back up at the Ciena more enterprise environment and have everything run. So we're really excited about that. So we did learn a lot today or throughout the week. So just a brief reintroduction of Gladius. We are a decentralized content delivery WAF and DDoS solution. And it's really just a piece of software that can run in Docker or VMware or anything else. And we're using Blue Planet to orchestrate that across multiple devices. We started off with really the concept of orchestrating it to a 3906, which has x86 boards in it. But really, we were able to attach it to VMs that are running on my machine, even a Raspberry Pi. And so we were able to push these Docker images down to these devices. And then ultimately, that was step one. I think ultimately the extension of this is going to be registering the devices and then pulling data off these devices to determine the health and status of them during their lifetime on the network. So first of all, I want to give a big thanks to Keith Kerr and Gretchen Magan. I got that right? Megan. Got it. Almost close. And then Jeff for supplying the LTE for sure and his unbridled enthusiasm for the 3906. And Bruce for giving us the opportunity to come here. Being around some of you guys, who I know we didn't really interact as much as we could have in the past, maybe in future hackathons we'll be able to do that. But the use cases that you guys I heard in the initial presentations that you gave us a lot of ideas on how we could extend this on layer 0, 1, 2, and 3 networks. Because really we're just an application. So as a VNF, we can just kind of layer on top of that orchestration piece. And given that we operate a piece of software that exists so close to those layers, the content delivery and eventually DDoS protection, it almost goes hand in hand with those networks and those network functionalities. So let's just do a brief overview here. We're scalable, decentralized. Essentially, we're taking the idea of content delivery and DDoS protection, verifying node transactions and node existence with blockchain technology. And then we're extending that so that those nodes can live anywhere. So think of anywhere on the network that you want to spin up content delivery nodes or even DDoS mitigation capability. You can do that. And using something like Blue Planet, you can orchestrate the creation and destruction of these nodes dynamically given network events. And so that's kind of where the idea of being at this hackathon came from. So yeah, it's a software solution. It can exist anywhere. It's really just a Docker container in this instance, but it can run on bare metal or VMs or up in the cloud somewhere. So your network and your ability to deliver content can now exist basically anywhere that you have access to and anywhere that you want to extend that capability. So given that network links go down or fibers get cut, any major network event that it can occur, we can dynamically create content delivery and DDoS protection on the fly. So we're using blockchain to fortify that network and to authenticate, because in that environment, how can you trust that the nodes that you've created and stuck out on infrastructure that you may not have direct control of belong to you or aren't being tampered with by somebody else? And so that's why we use blockchain. Blockchain enables the nodes in deployment to trustlessly verify each other that post to the blockchain, and then operators such as yourselves can now use that data to ensure that the content that you're pushing out on those networks isn't being tampered with in a malicious manner, and that also you can get real-time verification that those nodes are up and running and that they're responding to you in the correct way. So Blue Planet is a pretty large orchestration platform, and we've talked about other orchestration ideas in the past. The evolution of orchestration has really taken a long time to kind of evolve and turn into something where I think Blue Planet sits at the apex of what it can be. As an application, as a VNF application, we think that we can take orchestration and touch hardware and layer on software pretty much instantaneously. And because the software is pretty lightweight and easy to use, we think it basically goes hand in hand. It should be very easy to push this software in any deployment that has the ability to not only create demand or bandwidth on the fly, or links on the fly, or network connectivity on the fly, but also understand where those resources are, how many of those resources are available, and whether or not we can utilize those unused resources in real time. So we hope to take the idea of what we learned this week and extend the DevOps toolkits and the APIs so that we can interact directly with our software in the future. So today or this week, we had to break our software a little bit to work in a lab environment, and we had to rewrite pieces of it to make sure that they responded to scriptable commands from Blue Planet. But we think in the future, in the near future actually, the direct API application that Blue Planet has can lock directly into the application and make changes to that application, without needing CLI or without needing kludgy commands to do so. And then getting real-time response from that, and then seeing that post inside of a Blue Planet, interface or some other interface that interlocks with Blue Planet itself. So really, our setup was fairly simple here, and Keith is probably going to have to go over how the orchestration inside the 3906 worked. Again, thanks for Jeff for getting us the internet, because we needed that to talk to the Ethereum blockchain. But essentially, the way that our networks can be set up here is that you need two types of nodes. You need a master node that basically is a control of the network, is a control of the content or the origin server relationship, and then the edge nodes, which host the content from those origin servers, the static content really. That's what a CDN does. And so all of these, the edge node and the master nodes that would exist here in a VM, need to register to Ethereum blockchain so that they all can be, the state of those machines and the existence of those machines can be verified in real time, right? And so really the idea here was to spin up multiple Docker images on the VMs. I could extend this in as many ways as I wanted. I could just build out 10,000 VMs. I could orchestrate that through Blue Planet too. And then as long as I could push out the Docker software and then execute the commands that pulled our software from our repos, either on GitHub or a private repo as well. So really the logical steps there aren't too hard to imagine. So yeah. Keith, do you want to grab a couple seconds here and explain what he had to do? So Keith was instrumental in making sure that our software locked in. Unfortunately, we ran into some snafus, but Keith really understood how to pull our software into the 3906 platform specifically. So,
you got to stand close. So I can...
Yeah, we got to get real close here.
So what we did on the Blue Planet side was just we leveraged the NFVO solution in Blue Planet to deliver the Gladius VNF onto the 3906. I think in the future, as Patrick talked about, delivering it anywhere onto any piece of hardware is possible. It's just at this point the virtual infrastructure manager that is supported on that is either an OpenStack environment or our DNFVI software. And so we leverage that to actually deliver the master node software onto the device and create a service chain that attached it into the WAN network. So that was step one of just getting the VNF up and running. We can apply a day zero config, which would put some initial configuration on the device, so it would be able to connect, right? Whether it's DHC, in this case it was DHCP, so it came up pretty easily on that. And then we needed to do another step is just getting them onboarded into the system. So we created a new RA that communicated with the Gladius software. It's a Ubuntu based software in one case. In the other case, it was running on a Raspberry Pi, so it was running a Linux variant for that. But in both cases, we were able to adapt the RA so we could attach both to a master node and to an edge node that was on the device. And so those came into the platform once the NFVO architecture or the NFVO model was and the network design was instantiated on the master node, and then the edge node already existed on the Raspberry Pi, so all we had to do was attach to it directly on a running instance. And then we began to just create. We created a new service template, which I generically called CDN for the content delivery, and it contained just a few elements. One was selecting which master node you were going to use, what edge nodes were going to be connected into this CDN network, and then behind the scenes, all it was doing was going off and running the Docker commands that were required to spin up the software on those devices. So each of the devices had a different Docker Compose file or a variant of a Docker Compose file to run. So this RA could or this service template would just make calls into each of those devices and run the necessary commands. And again, we're just leveraging the standard RA toolkit for developing RA commands that can run, and then we're just triggering those from this service template. And so then that basically creates the environment with which their software needs to work at that point. So I'll hand it back over to Patrick to talk about the rest.
Thank you very much. So as you can imagine, if we didn't have Keith, we might as well not have even been here. But Keith was very instrumental in helping us understand that. And in the future, I'll be working with some Ciena members as well to get documentation and learn how to do some of this as well on my own. So the extensibility of this is huge for us, and we really think that our application becomes so much more powerful in an orchestration environment, because really at that point in time the power of the enterprise takes over, right? And their infrastructure becomes our infrastructure. So what do we learn throughout the hackathon? Orchestration is not easy. It certainly takes the cycles that we were talking about before with Jeff are apparent even in a very short, compressed time frame, a 1-week time frame. Taking a piece of software that's never existed in an orchestration software or orchestration environment and making it run on hardware that's never run on before is a daunting task, especially when you're running up against limitations of the lab environment, or trying to understand how one piece of software interacts with certain commands inside the orchestration software. So it's really just the cycles are super important, and the more we iterate with that, or the more we interact with that, the faster we can iterate those fixes. There are many layers of the network stack to consider when deploying resources, and so being in the room with major ISPs or carrier networks, you guys have already given us ideas as to how to layer on our service on a much larger scale, either globally, transoceanic, even regionally. How can somebody who's operating a fairly large-scale network take our software and then use events that they're using to trigger whatever changes they're making on their network to implement our solution as well, or dynamically move our solution around their network, right? So why is this application really relevant to the hackathon? Like I said before, the layer 0, 1, 2, and 3 operations are occurring as a result of efficiencies that we're seeing through orchestration software. So we see efficiencies or inefficiencies on our network, and we correct those using automation, right? And if we can layer on applications at the same time, we're making our networks all the more powerful, because ultimately the networks aren't just there to transit nothing. They're there to transit data and services and content and things that people consume on a regular basis. And so content and ultimately the security of that content is going to be truly crucial and critical to the deployment of these lower level services. IFTTT is one of the other applications that was talked about during this hackathon. The auto scaling and capability of creating if this then that logic and applying that to a piece of software that can live anywhere and spin up anywhere and register from anywhere and deliver content from anywhere makes the marriage of IFTTT and Gladius and even orchestration software like Blue Planet, it's almost seamless at that point in time. It should almost be a given at that point in time. And then even dynamic charting. Lucidchart, or any other application that Blue Planet can log into, it allows visibility, because if we don't have, we're still human beings. We still need to see things to understand them. And software that can live anywhere at any time, it could be difficult to map that out, right? And it's almost useless to map it out manually, because now we're taking time out of our day to draw something that could change overnight, right? So allowing orchestration software to dynamically create that charting gives human beings an easy way to ingest information on the fly and, almost effortlessly. So that's it. That's our presentation. So you guys have any questions?
With your VNF, I mean, you had this VNF for a while. How were you deploying it previously? Like, it was basically just on like servers in a central location. How would you spin up new instances?
Well, the VNF in and of itself, this is the first time it's actually existed as a, I guess, official VNF, right? So we're a beta application. We're still building out the functionality, and we're still building out the scalability. But right now, it's just manual push to an end user. Our clients run on Macs, PCs, Windows, or Linux. So really, we've developed GUIs for Macs and PC and Windows, and then we've also developed scripts for Linux machines that just spin up. So we haven't moved to the point of orchestration yet. One, because orchestration is difficult. We're developing an application, so the two, we don't have the cycles to do both right at the moment. So, but it's opened up our eyes as to what needs to occur for this to become a viable enterprise product in a shorter amount of time. So,
Like you said, it sounds like your end point where you're delivering the software is enterprise. But what about have you looked at how you could offer this to carriers who can use the orchestration to push it out and offer as an end service themselves?
that's one of the use cases we've looked at. So carriers being able to deploy this either throughout their stack, I mean, from data center all the way down to some POP, but further. Well, what about cable modems that can run x86 or ARM or whatever else it may be? What if we can run applications right on those devices? What about DVR devices that have spare capacity? What about the end user in their home who has computers that don't use it 99% of the time? What if they could serve up content? We've made that possible actually already. But the orchestration of it still requires some partnerships with ISPs to kind of break down the use case and give us a little bit more insight as to how they would like the application to behave in their environment. So
your next steps, you hope to go back and leverage MDSO, start building up RAs or developing the RAs that we kicked off here, right?
yeah, so I think we'd really like to tie in and learn more about the RAs and tie it directly into our application, because there's a lot more there than just executing a string, right? There's APIs that can tie into our application. There's a number of other opportunities to dive this thing down a little bit deeper.
And you hinted a little bit into closed loop as well, where you can monitor the network, and as networking volumes, you guys can adapt to response.
That's something we'd love to see, the automation of this. Now, again, because the nodes work in a trustless manner, we can spin up a node anywhere, even if it was on an untrusted device, and still trust that the content we're delivering to it isn't going to be tampered with. So now our network extends beyond our trusted border. So even in a new deployment, even in a deployment that's very far away from head end, we can still deploy content, and we can do it in an automated fashion. And so the automated piece of it becomes very important to us. And I think anybody who wants to orchestrate this software.
That plays well with where we're hoping to take MDSO, right?
Yeah, absolutely.
What I was going to take back is like, okay, so who's going to take the lessons learned here? Because in the end, this is just one of the partners that we want to do this with, right? Yeah. I mean, there's a long list of partners we want to do this with. And we've got to, what I was going to ask was, okay, what could we have done better? How painful was the process? And how can we make this process easier? And I'm looking at Jeff because I'm going, Jeff's probably the best organization that has gone.
Yeah.
So Jeff's probably like, why are you looking at me?
Yeah, he's like, thanks, appreciate it.
Task assignment I've ever heard.
Yeah.
But I do think that we need to basically gather what we could have done better to make this process easier because we have a number of VNF partners that we want to do this with,
Yeah.
and we've got to make it where it's just less painful.
Right. And I think I could probably provide a lot of insight to that. We did experience quite a bit of pain, not just because of the MDSO, but because we're bringing a raw application into an environment that isn't ready for that, right? And we had to tweak the hell out of it just to turn it into an application that run on a local network. It wasn't designed to do that. So there's a lot of little, and it's going to be separate use cases for each person.
Because our goal in the end is that we are the orchestrator for all these VNFs.
Sure.
Our customers are out basically picking best of breed VNFs and just plugging them in, right? And then they can basically offer all these different services across their, across their compute.
Sure.
Distributed compute, right?
Yeah.
So in the end, this is where we want to go. So making this process easier helps everyone.
I appreciate you guys. We've been working with VNF vendors for quite a while. We have many of them integrated into our solution already. However, this is the first time we've got a VNF vendor active for our hackathon. So
Yeah.
appreciate you guys dedicating the week.
No, we appreciate it, and we hope to come back to any more that you have, and then next time, hopefully, we'll take what we've learned this time and apply it, make it a lot more efficient, so we can collaborate a little bit more with some of the other participants and turn it into something more useful for them.
Cool.
So.
Any other quick questions? We got to keep this moving. See, we got, who are we missing? We got Kim and Christian. Oh, sure. Yeah, the other people from them on service chaining, any constraint in terms of response time.
I'm sorry, are we? Yeah. Oh, are there any constraints? There are going to be mild constraints in terms of how it can register and how services spin up. So again, we're an application that is decentralized and can be moved anywhere, but it's still a computer, right? It still needs to spin up service. It needs to wait for registration. So there's some orchestration techniques that we're going to have to get used to before this thing runs seamlessly in most environments or all environments.
And there's really only one VNF running, so there's any VNF app there already. Is it more along those lines, or?
Well, he's talking about service chaining maybe inside like a 3906 or something else where you have to patch together networking along the way. So there's.
Yeah, they're waiting for answers to come back and forth.
Yeah.
Back and forth. What's the impact of that?
Yeah, and that's going to take a lot more lab testing from our end.